Hello guys, today we start to study chapter 5, Matter and Heat. This chapter contains 19 sections, divided into 4 parts. We will learn about temperature and heat, fluids and kinetic theory of matter, changes of matter states, and heat engine and thermodynamics. Temperature is a physical quantity to measure matter hot and cold. In an atomic view, it is a measure of average kinetic energy of molecules. A device to measure temperature is called thermometer, which is made usually in terms of the expansion of substance when it is heated, such as the mercury thermometer. Temperature has 3 popular scales. The first is the Fahrenheit scale, defined by choosing the water freezing point as 32 Fahrenheit degree, and the water boiling point as 212 Fahrenheit degree. The second is Celsius scale, defined by choosing the water freezing point as 0 Celsius degree, and the water boiling point as 100 Celsius degree. The Celsius scale is much simpler than the Fahrenheit scale. We can relate the two scales by this formula. Fahrenheit temperature Tf equals 9/5 times Celsius temperature Tc plus 32. Another scale is called absolute temperature, which is defined as the Celsius temperature plus a constant given by 273.15. The unit of the absolute temperature is Kelvin, shortened by K. It should be noted that the absolute temperature can never be equal to or less than 0, and all physical formulas use the absolute temperature. As an example, a temperature of 20 Celsius degree is equivalent to 68 Fahrenheit degree, or 293.15 kelvins. As we already knew, heat is a form of energy. Now we can further say that the heat in the body is the internal energy, given by the sum of the kinetic energy of all molecules that make up the body. Adding heat to or removing heat from an object causes the object to increase or decrease its temperature. The heat added or removed and the temperature change can be related by this formula. Q equal mc times T2 minus T1. Here m is the mass of the object, T1 is the initial temperature, T2 is the final temperature, and C is the specific heat, defined as the heat required for 1 kilogram matter to increase temperature by 1 degree. For water, the specific heat is equal to 4.2 kilojoule per kilogram per Kelvin or per Celsius degree. For example, find the heat needed to heat 2 kilogram water from 30 Celsius degree to 100 Celsius degree. From the heat formula, Q equals mass m times the specific heat of water, seawater, times the temperature change, T2 minus T1 equals 2 times 4.2 times 100 minus 30, then equals the result equals 588 kilojoule. Food contains energy also, which is usually called metabolic energy. The unit for food energy is usually kilocalorie, shortened by kcal, with 1 kcal equal 4.2 kilojoule. Food energy is liberated For living organs via biochemical process called metabolism. Exercises increase metabolism. This table lists the energy content of some food to be liberated. For instance, 120 kcal energy can be liberated from a banana. To liberate the energy of a banana, a 50-kilogram girl needs to climb a mountain of height, based on the calculation, equal 1,028.6 meters to work out against the gravity. Matter refers to any substance in the universe. Matter exists normally in three types of states: solid, liquid, and gas. Solid has a definite volume and shape. Liquid has a definite volume but not shape. And gas has neither a definite volume nor shape. Mass per unit volume defines the density of matter. That is, the density D equals mass m divided by volume V. D equals m over V. Different kinds of matter have different densities. This table lists the density of typical matter, from which we can see the density of air is 1.3 kilogram per cubic meter. Density of pure water is 1,000 kilogram per cubic meter. Seawater a little bit higher. Ice is 920 kilogram per cubic meter, less than pure water, and so on. For example, find air mass in the classroom. From the density formula, D equals m over V, we have mass m equals density D times the volume V. Density of air equals 1.3 kilogram per cubic meter given by the table. Volume of the temperature can be measured if the length, width, and height of the classroom are measured at 6, 5, and 2.5 meters respectively. Then we have the volume of the classroom equals 6 times 5 times 2.5 equals 75 meter cubic meter, and then the mass of the air in the classroom equals 75 times 1.3 equals 97.5 kilogram. Another important parameter to describe matter is pressure, which is defined as perpendicular force per unit area, P equals F over A. The unit for pressure is Newton per meter square, and by a new name called Pascal, shortened by Pa. 1 Pascal equals 1 Newton per meter square. For example, find the pressure on the air in the pump, whose piston with a cross-section area of 0.001 cubic meter, the square meter square, okay. That's the area because from the pressure formula, P equals F over A equals 150 divided by 0.001 equals 150 kPa. That's the pressure on the air in the pump. Pressure in fluid increases with depth. The air pressure at the sea level is given by 1.01 times 10 to the 5 Paul, which is defined as by 1 atmospheric pressure, 1 atm, or 1 bar. A device to measure pressure is called a barometer. When an object is immersed in a fluid, the object will be exerted by an upward force by the fluid, no matter the object floats or sinks. This force is called buoyancy or buoyant force. Archimedes' principle or law tells us how to determine the buoyant force. It says that the buoyant force on an object in a fluid is equal to the weight of the fluid displaced by the object, Fb equal dvg. Here, d is the density of the fluid, g is the gravitational acceleration, 9.8 meter per second square, and v is the volume of the fluid displaced by the object. For example, find the buoyant force that exerts on a 50 kilogram spherical object with radius of 0.3 meter by water. When the object is entirely immersed and is partially immersed. For the object to be entirely immersed, we can calculate the buoyant force from the buoyant force formula, Fb equal dvg. Since the density of water is 1,000 kilogram per cubic meter, G is 9.8 meter per second square, and the volume displaced by the water, displaced by the sphere, can be determined by the volume of the object because the object is entirely immersed. Therefore, the buoyant force, Fd, is equal to 1,000 times the volume of the sphere, 4/3 pi times the radius, 0.3, the cube, times 9.8, that's the g. Multiply together, the result is about 1,108 Newton. For the object to flow on the water, we can determine the buoyant force based on its weight because it's balanced. So in this case, the buoyant force equal the weight of the object, mg. Fb equal mg. Mass m is 50, g is 9.8. So 50 times 9.8 equal 490 Newton. Thanks. We will continue this chapter after midterms. So this is part A of chapter 5. We will give you an assignment after this chapter. So see you. Bye bye.